Okay, so in this video I want to talk about derivatives and why working with derivatives is important in economics, and I want to explain some basic derivative rules. But let's start first with some of the intuition. So this will be a video about derivatives. So let's begin again by looking at the typical utility function and the law of diminishing marginal utility. So let's say you can consume cookies and you can have 0, 1, 2, 3, 4, or 5. So obviously the more cookies you have, the more utility you will get from consumption, but the extra utility that you get from each cookie is becoming less and less. So if you take a look at the total utility, and I abbreviate it with TU, then let's say if you have, of course, 0 cookie, your total utility is 0. But if you have 1, the first cookie, it's very delicious, and you feel like you get a utility out of it that you value with 5. So you would pay up to $5, let's say, to get that first cookie. Well, having a second cookie is still great, but it doesn't taste as great anymore as the first. So let's assume your total utility goes up to 9. And then if you have a third cookie, having a third cookie is good too, but it probably is not as great anymore as the first or the second, so your total utility goes up to only 12. If you have a fourth cookie, your total utility maybe goes up to only 14. And if you have 5 cookies, your total utility goes up to 15. Okay, so now if you always look at the difference in total utility from one cookie to the other, so the first cookie gives you a total extra utility of plus 5. Then the second cookie adds another 4. The third adds another 3. The fourth adds another 2. And the fifth adds only another 1. So this is the marginal utility. Or actually, to be more specific, it is called the incremental utility. And the difference between incremental utility and marginal utility is that here we have an increment of 1. Marginal means it's not 1, it's very, very small, like 0.001. In fact, marginal would mean that the distance between one cookie and the other cookie is so small that it's basically like a crumb rather than an entire cookie. But anyhow, let's just stick to the term marginal utility for now, but keep in the back of our mind that it's actually in this particular case the incremental. So the marginal utility of the first cookie is now 5, and then 4, 3, 2, and 1. Okay, so now what does that mean? Let's draw the total utility function. So if we draw it, we can so we put the cookies, let's say cookies is x. So we put cookies x on the y-axis and the total utility on the y-axis. So we represent the total utility as a function of x. So x in this case is the independent variable and the total utility the dependent, because the total utility depends on the consumption of cookies, which is x. Okay, so let's say here we have 1, 2, 3, 4, 5. So 1, 2, 3, 4, 5. Okay, so the maximum is 15, and then maybe here this is 10, and here maybe we have now 5. Okay, so if you have, no, let's maybe different color. Okay, so if you have no cookie, no utility. If you have one cookie, total utility is 5. So let me look at this column. So that would be here. If you get 2 cookies, your total utility is 9. So that's a little bit below the 10, maybe here. If you get 3 cookies, your total utility goes up to 12. Maybe that's around here. If you get 4 cookies, your total utility is around 14. Maybe that's around here. And if you get 5 cookies, your total utility is 50. So that would be here. So if we draw now a total utility function, you can see that it is increasing, but it's increasing at a diminishing rate. So there's some curvature to it. So that would be a total utility function. So the marginal utility is basically informing you about how much extra utility can you get if you increase the number of cookies by a very, very small amount. And in fact, it is such a small amount that it fits over one point. So let's assume we take a look at this point here. Let's call this point A. And now what I do is I put a magnifier glass on top of this A and I zoom it in. So this is A zoomed in. So this is now a huge dot, right? So this is the same A, but I magnify it. Okay, so now in this point A, that point A, there is a slope. So now if you put the point of tangency there, you can see that slope has a certain value, and it's pretty steep. And it is much steeper than, for example, here. If I put a point of tangency at this point, in point A, this is much steeper. So obviously, so there's like a, so this point has a slope. Okay, so now we have a slope, and the slope is defined as the rise over the run. So now in this point, we can disentangle, it's maybe a different color, light blue. So the slope is the rise over the run, so the rise would be this distance. And because everything is so small, we would call this distance in this point the change, and we just write the d, that means it's very small change, t u. So the rise is the change in total utility here. And the run is the change in x. So in other words, the slope is, at this point, the rise, which is the change in total utility, over the run, which is here. So in again, this point A is having, like, you know, here, this distance here, this vertical line is the change in total utility if you increase a little bit x. So if you have here a little bit plus dx, then you get a little bit more total utility. But how much that extra total utility is depends on the position of the total utility function. And we can see in point A, this utility is, that marginal utility is much higher than in point B, and point B is much higher than point C, and point C is much steeper than point E. Because if you always look into it, the slope becomes flatter and flatter. Well, if you take a look at this slope and we just say, at this point A, which is the marginal utility, we try to find the marginal utility in point A, so maybe this is 5, so the slope is 5, and that corresponds to the marginal utility of 5, and here it is 4, and here it is 3, and here it is 2, and here it is 1. So then, the marginal utility, if I take this graph and I derive from it, without going into math for now, the marginal utility, then the marginal utility can be written as the marginal utility, which is nothing else but the change of the total utility relative to the change of x. So this rise over the run relationship. And then maybe here we have 1, 2, 3, 4, 5. And here we still have 1, 2, 3, 4, 5. So 1, 2, 3, 4, 5. So then the marginal utility is a downward sloping curve, because the marginal utility in point A, the slope here is 5, and at 2 it is 4, and at 3 it is 3, and at the fourth point D it is only 2, and then it is 1. And then we get like a marginal utility function which is such a straight line. And it's going down. Okay, so that is the marginal utility, the idea or the concept behind the marginal utility. And then we said, let's say you have to pay for every cookie $2. So that means the marginal cost, the cost that you have to pay for each cookie is always 2. So that is a straight line. Let's give this a different color, maybe, I don't know, green. So that means marginally the marginal cost is always 2. So for the first cookie, if you have to pay 2, but you get a utility of 5, well, of course you have the cookie because you get this distance here in extra surplus. And then you say, shall I have a second cookie? And then you say, okay, well, the second cookie gives me an extra utility of 4. I'm craving it so much, I would pay up to 4 for it, but I have to pay only 2. So now I get this distance in surplus. For the third cookie, actually gives me a utility of 3, but I have to pay only 2, so I still get a little bit of surplus. But the fourth cookie gives me exactly as much extra utility as I have to pay for it, so I'm basically indifferent. And then we like to say whenever an individual is indifferent, we actually consume the word. But you will not have a fifth cookie, because why would you pay another $2 for a cookie if your willingness to pay and your marginal utility from it is only 1? So that means the profit maximizing or the utility maximizing consumption of cookies in this case is 4, because up to 4 cookies your marginal utility is always greater than the marginal cost. And you maximize utility, so the utility max is always where the marginal utility is equal to the marginal cost. So the marginal cost is always constant, so that's a straight line, so that's the marginal cost. And you see at 4 cookies, at the fourth cookie, we maximize our utility. So to make a long story short, the marginal utility informs about, well, first of all, mathematically, it informs about the slope at every point of a function. So the marginal utility would inform that at a point 1 the slope is 5 and the slope at point B is 4 and so on. So the marginal utility informs about the slope at every point of a function. But of course what's very important economically is that the marginal utility informs about how much extra utility will you get if you increase the level of consumption by such a small amount that it will fit over one point. So in other words, if I had said, I increase it from 0 to 0.1, so let's say if the original example would have been, from 0 to 0.01 and from 0.01 to 0.02, that would be more in the spirit of the marginal utility. So technically here, when we started out that example, that is what we call the incremental utility, because increasing cookies consumption from 0 to 1 and 1 to 2, that's in economic terms a lot. And of course we assume that you can break down the cookies consumption into super small units so that they basically fit over one point on the curve. And then once we do that, we can see that the utility maximizing condition must be always there where the marginal utility equals to the marginal cost. Okay, so that's the intuition. I'll just stop here for now. And then we can work maybe with some other examples and examine and get a little bit of feeling for the marginal perspective on different kinds of economic functions. But I'll stop here now.